Hello. You can see the email, so I'm sorry because some people are using the classroom right now. So,
Are you all here for GPSA?
we need to.
No, for the SAS thing.
Well, it's the organization and you have to sign in to get credit, but if you're not, you don't have to sign in.
I didn't know what it was.
Oh, okay. Yeah.
I think they are for.
Could you move the?
And you can sit anywhere once here.
Yeah.
Thank you.
Hello everyone. We have a classroom issue, so I'm so sorry about your inconvenience right now. So. Can you hear me now?
Yes, we can hear you.
Thank you so much. Let's start with our workshop. So, hello everyone and welcome. Thanks for being here. Today we are going to talk about the SAS Essentials for data analysis. My name is Inan Jung, and I'm a master student in applied data science. And
my name is Princess. I'm also one of the statistical consultants at the Statistical Consulting Lab. I'm pursuing my master's in mathematical sciences.
This workshop is intended for people who are not familiar with SAS programming. In this session, we will learn about how to use the SAS program. We will go by step by step and walk through the example together. Let's start with. But before the workshop, I'd like to briefly introduce my the statistical consulting lab, and the lab is located in the room 308M and Gilbert Hall, and you can watch the introduction video using this link. So we are walking through weekdays, and if you have any problem with your research, and if you have any related to the statistical program, we are here to help you. And then if you want to have an appointment, and then you can send us an email, and you can drop by our office. And here are our today's presenters. And let's talk about the SAS. A SAS, or a statistical analysis system, is a powerful statistical tool to manage the data set and to apply the statistical techniques. And the SAS can provide the visualization methods such as the histogram and the time series plot, something like that. And then many industries are using the SAS, such as the healthcare and social science field and the business field, because SAS can handle a large data set, and then SAS can produce the reliable result. So And using the SAS, we can handle the large amount of the data set efficiently. And then SAS has variable statistical technique to identify the hidden patterns from the data set. And you can create the high quality plots and chart. And in your research, SAS can be applied to analyze the experimental data and the survey data and the observational data. So SAS can help you make a data-driven decision, and you can forecast future trend using SAS, and then you can test your research question using the SAS program. We are using, in this workshop, we are using the SAS OnDemand for academics. The SAS OnDemand is an online-based SAS program, and you can use the SAS OnDemand free of charge after registration process. And well, we will show the SAS OnDemand. So, and we will introduce how to use the SAS OnDemand, and you can we will introduce the how to import the data set using the SAS OnDemand later. In this workshop, we are using the SAS OnDemand, and we will cover the basic SAS programming, and we are going to talk about how to upload the data set and how to explore the data set using SAS, and we will conduct the ANOVA test using SAS, and then we will perform the multiple linear regression. Before SAS programming, there are basic rules you need to remember in SAS program. And first is every statement in SAS must end with the semicolon. So if you don't use the semicolon, the code you don't run the code. So you need to end with the semicolon on every line of the after the code. So the second is SAS is not case sensitive, and third is we usually start with the data and prop at the initial step, and next is you need to run RUNs semicolon to tell SAS to complete this code and run the code. So you will see this all part later. So the next is you can put your comments on SAS code using the asterisk or asterisk semicolon. You can see this comment thing later. And lastly, you can see the dots in your data set in the SAS program. Dot means the missing value. So we will talk about this later. To start with working with your data set, you need to import the data set to the SAS program. So generally, prop import and data statement are used to import the data set to SAS program. So actually, especially prop import is used to read the text format or CSV format and Excel file, and data statement is used for the SAS data file, such as the SAS 7B DAT format are imported to the SAS using the data statements. And if you want to input your data one by one in the SAS program, you can use the data statement with the data line, and you can see those things later. And below, you can see the basic syntax structure of the data and prop import statement. I will explain the line with the SAS OnDemand later. Once you import your data set to SAS program, we need to understand how this data set looks like. And there are 4 basic SAS commands to explore the data set. The first one is a prop print command. You can use the prop print command to understand what the data set look like. And second is the prop contents. This command provide the basic information about the data set, such as the variable name or data type, or how many observation the variable has. So yeah, you will see this command later. So next command is prop means command. Prop means statement provide the summary statistics such as the means, standard deviation, minimum value, and a maximum value. The last thing is the last thing prop frequent is help you to identify the identify classes in the categorical variable. You can see you can see the result later. Let's go to the SAS OnDemand for our what I had talked before. So I will share my SAS OnDemand screen. And this is the SAS OnDemand. You can upload your data set using this button, and you can create your SAS program using this button. So if you want to know more about this, and you can register for the SAS OnDemand, and you can explore all of things. Yeah, this is the free of charge. So, and first we are talking about this importing data set. Here is the SAS code for importing data set. And first, first thing I'm going to talk about is prop import. Using prop import statement, you can import the data set such as the text format, CSV format, and Excel files into the SAS program. So you first thing you write the prop import, and you set the data file, and this is the file path of your data set, and you can see your file path using this property, and you can find the file path using this one, and you can copy and paste and this area. So yeah, and our statement means the data set in SAS program. So when you want to use the data set in SAS program, you can write this data set file, not this one.
Which one?
This one, my data.txt.
Okay.
This is the data set name in the SAS program. Just And DBMS is the file format. GLM is the TXT file format. So you need to set the DLM to import the text format file into the SAS program. So replace means you can recreate the same name data set using this replace option. So what you need to notice about this code is the location of the semicolon. The semicolon is only semicolon is here, so you don't need to write the semicolon here and here. So you need only one semicolon here. And the limiter is how the data set how the data are separated. So 09X means the tab separated. So if the data set are separated with space, you can write these things. This means space. And get name statement means that you can get the variable name from your original data. So let me run this code.
What are you delimiting?
Sorry, can I ask the question? How did you get to this?
What are you delimiting?
I'm sorry.
What are you delimiting?
Delimiting means how the data set separated. I can and let me show the data set. So, and this is the data set we are using, and you have a data and observation 1, and you have two data, 700 and A, 850 and A, and you need to separate this.
So it wasn't separated and you're separating it?
Yeah.
Okay.
So the TXT format in this data separated by the tab. So you need to set this to set which sign separate the populations of new data sets.
Thank you.
Yeah. Next is the CSV format file, and you need to change the DBMS, this thing CSV, and you need to change the data file path. So I have I have a data here. I upload the data using the SAS OnDemand, and then run the code, and the same data is shown. So go back to the code, and you can import the Excel files into the SAS program, and you can run. You need to change the DBMS options. You need to write the XLSX because the data format is XLSX. So you need to change the data file. So, and this one is not working now. So, and run the code. You can obtain the same data set. So, if you wanna use the if you wanna use the data statement, so you can use this command, but this data statement this data statement is used for the SAS data. SAS data means this is SAS 7B format data set. So you need to set the data set. You need to label the data set here, and you write the set, and you need to you need to write the file path this area and semicolon, and let's run it. So you can obtain the, SAS data set. This is the different data set. So next, you can use the data statement to import the CSV file. So you can write this code, and you need to infile means the file path of the data set, and DLM is the comma separated. CSV file is a comma separate data set. So, and here, let's learn this, and you can obtain the same data set. And if you wanna input your data set manually, you can use the data statement with the data line. So I input just the data. I input the observation manually. This thing, and input means you assign the variable name to y and x1, and this line is the y, and this line is x1, and you write the data line and you input all of the observation in your data set, and this dot means the missing value. So let's run the code. So yeah, this is the data set we obtained using the data statement. So you can check the frequency by using this statement, and you can you can learn about the how the data set look like, and as previously before I showed my data set, and I input my data set before, and y value is you can see the frequency of each value. So yeah. And next, and I can provide all of the SAS code to audience. So if you need my SAS code, please send me an email or request me about this SAS code. So next is the data analysis code, and first thing you need to do is import data. And this output data means the data set you obtain right now. So, and next is the print data, but it is not working because I need to highlight all of things, but I missed the one thing here. So you can see the error in this log page. So let's rerun the code, and you can see all of the information about the. No. Here.
Okay.
And to obtain the summary statistic, you can run this code, prop means, and you can get the basic summary statistics such as the count, means, standard deviation, and minimum, maximum. If you wanna get the different standards, different summary statistics such as the median, range, or mode, something like that, and you can use the different. You can write the different statistics such as the median and range and something like that. I'm running both code, and you can this is the default output, and this is the specific output. So yeah, default output provide the number of observation and mean, standard deviation, and minimum, maximum, and this is the different statistics. And if you have a categorical variable, you can you can identify how the categorical variable looks like, and you can use the frequent. Yeah, you can see all of the frequent output, and there are two variables. One is the written. One is the words and one is the method. And method is a three. Method has three groups: A and B and C. And in this data set, there are 15 observations, and group A has 5 observations. Group B has 5 observations. So you can see the basic information about the data set. And if you want information about the data set, such as the labels and data type, you can use the prop contents. So in this result, you can see the basic information, and in the last box, you can see how many of the data, how many observations the data set has, and there are two variables, and then you can see the variable. You can see the variables information. So and variables type. CHAR means the character type. It is the categorical variables. So NUM is the numerical variables. This is the data analysis code. And next, we're talking about ANOVA test. Okay, ANOVA stands for the analysis of ANOVA. Is a statistical method to compare means of the different groups. So if you have the 2 or more than three groups, you can apply the ANOVA technique to compare the means of the different groups. So we are using we will apply the one-way ANOVA to examine the differences between the 3 groups. And one-way ANOVA is can be applied when we have one numerical dependent variable and want to compare it across the different groups or categories. ANOVA is very useful when comparing the multiple groups, when checking the effect of the factor on the dependent variable. Additionally, if we have more factors, the 2 or 3 factors, ANOVA can identify the interactions between among the factors. This is the ANOVA code in SAS program, and in the right side, this is the ANOVA a syntax text structure in SAS program, and the first line starts the prop ANOVA, and in the second line, class statement split the dependent variable into the groups based on the the categorical variable, and in the third line, the VAR is the dependent variable. This VAR is the I just made this label, so VAR. So category is an independent variable for grouping. So the last line means statement can show the average of variable for each categories. You will see that all of them using the SAS OnDemand later. And in one way, ANOVA, we can conduct the hypothesis test. The null hypothesis test is, H sub 0 is that there are no significant differences between the group means. On the other hand, the alternative hypothesis says that at least one group is different. So based on the result from the SAS program, you can find the p-value for hypothesis test. If the p-value is less than 0.05, which means the significant level, and the null hypothesis can be rejected, that is, at least one group is significantly different from the others. For ANOVA analysis, there are four key assumptions to satisfy. One is the dependent variable should be the numerical and continuous variable. Independent variables should be the categorical and qualitative variable. And third assumption is the experiment is randomly and independently designed, which means the one variable should not impact the other variable, and the observation should be selected by the randomly. And samples are normally distributed and has a constant variance. But there are some statistical tests to identify the normality and non-constant variable. But this option is for the basic level, so we skip the statistical test for normality test and the non-constant test. So the data set we are using is the world data. This data set includes 15 observations and 2 variables. And the worst variables has the number of the words per minute in the reading test. And the method variable is method variable has 3 categories: the A, B, and C. So let's go back to the SAS OnDemand. This is the ANOVA code in the SAS program. First thing you need to do is import data. This is the data set we are using. So next step is ANOVA. Yeah, here is the result. And in the first box means the first one means how many category in the categorical variable. There are 3 groups: A and B and C, and the variables have the 15 observations, and you can find the statistics about to calculate the F statistics. And the first line is the variation between the groups, and second error means the variation within groups. So this mean squared, and using the mean squares, and you can calculate the F values, the model divided by the error. So you can get these p-values. P-value is very low, 0.0003. So we can you can conduct the hypothesis test using these p-values. So, and you can obtain this box plot to compare the means of each group, and you can see the this box to see the means for the each group. So A group has has a 5 observation, and the means of the A group is 786. So you can see the mean value and standard deviation. So let's go back to the our in conclusion, you can get the F statistic, and F statistics is 16.78. And since the p-value is less than 0.05, and the null hypothesis can be rejected. Therefore, at least the one method has different mean of words. So this is the SAS code for ANOVA test. You can you can draw the conclusion from this SAS program. So let's go to the multilinear regression.
Thank you so much, Luan, for all the details. Next, we'll be talking about multiple linear regression. So what is multiple linear regression? So it's a statistical technique that's used to analyze the relationship between one dependent variable and multiple independent variables. So more than 2 or more independent variables. And you might be wondering, what are the key purposes of multiple linear regression? It can be used to analyze relationships. For example, in case we want to determine, we have data and we want to determine the prices of houses, and we have information or data on the number of bedrooms, the income of an individual, we can analyze the relationship between house prices and these other 2 independent variables. Multiple linear regression can also be used to control for confounders. Let me give you an example. So in case we want to determine the effects of exercise on weight loss, but then we know that diet can also influence weight loss. For instance, you might be exercising, but then you might not be eating healthy. So that can have an effect on whether you lose weight or not. And so the confounder here is the dieting. And multiple linear regression can help to control for that. The other key purpose of multiple linear regression is predicting outcomes. So with the example that I gave about house prices, we can use the number of bedrooms and then the income of an individual to predict the amount of or how much a house is going to go for. Why is multiple linear regression important? It's important for various reasons, such as it helps researchers to identify predictors of health, behavioral, or economic outcomes. It's also important for complex analysis, where multiple factors contribute to a single outcome. And it can also be used in several areas. I think Iwan highlighted a few of the areas, like the public health, social sciences, economics, and then business analytics. Okay, so we'll look at an example, and with the example that we'll look at, this a little overview of the data. So the data set consists of 24 observations, that's the rows, and then each observation represents a different instance of a real-world event. And there are 3 variables in this data. The variables are time, cases, and then distance. Time is a continuous independent variable that represents the delivery time. And this is what we aim to predict or explain. And for the cases are one of our independent variables for our data. And it just represents the number of items, packages, or products that need to be delivered. And then our second independent variable is distance. So it simply means the distance traveled during the delivery. So here we are trying to predict the delivery time given the number of items or packages and then the distance traveled by the delivery person. Okay. So these are research questions that we are trying to, we are trying to answer. So we have our null hypothesis, which is the number of cases and which states that the number of cases and distance do not significantly affect the time. Or in other words, no relationship between independent and dependent variables. So we can mathematically write our null hypothesis as H naught is such that beta 1 is equal to 0. That is for cases, and then beta 2 is equal to 0 for distance. Where our beta 1 is the coefficient of cases, and then beta 2 is the coefficient of distance. And for our alternative hypothesis, is the number of cases and distance significantly affects the time. So that is H1 is such that beta 1 is not equal to 0 for cases, and then beta 2 is not equal to 0 for distance. So in other words, we are just trying to test if the coefficients for cases, that's the number of items or products, and distance, the distance traveled, are different from 0. Okay, so now let's go to SAS OnDemand. Okay. Okay, Iwan explained how to input our data. So for this one, we manually inputted our data. So let's just run our data to see what we have. We can also print it out using the prop prints, just to view it in the results tab. So this is our data. We have our 3 variables: time, cases, and then distance. And then we have our observations. For point of correction, 25 observations instead. Okay. So let's go back to our code. So now we want to perform our multiple linear regression analysis on this data. So we'll just go ahead and run this. So here you can see the number of observations, 25. And this is the analysis of variance table, which gives us information on the model, error corrected total, sum of squares, mean square, the F value, and then the P value. So when we look at the parameter estimates, we can see the cases and then distance. And this is the P value is what we'll be drawing our conclusions on. So we can see that the P value for cases is less than 0.0001, which is very, very small. And that is less than our alpha value, which is 0.05. We can also see that the P value for distance is 0.0006, which is less than 0.05. Okay. And these are also some graphs. I'll talk about some assumptions later, and then these graphs help us to justify these assumptions. Okay. So let's go back to our code. And then let's talk about the variance inflation factor for multicollinearity. So multicollinearity is simply when the independent variables in our data are related. Usually when that happens, it has a negative impact or effect on our prediction. So it's usually advisable to test for multicollinearity in multiple linear regression. So let's check for that as well with regards to our data. And I'll go ahead and run that. So these are the values for the variance inflation factor. If you look at the parameter estimates table on the extreme right, it says variance inflation. I'm using the cursor around it, so those are the values you want to focus on. So we can see that for the variable cases, the variance inflation is 3.118, and then that of distance is also 3.118. So usually when the value for the variance inflation factor is greater than 10, then we can conclude that there's multicollinearity. But our values are less than 10, so we are safe. There's no multicollinearity here. Okay. So now let's tackle some visualizations. Now we want to look at the relationship between the independent variables and then our dependent variable. So let's take them step by step. Let's first consider cases. And then I'll go ahead and run it. This is the code, prog. So I'm just trying to generate a scatter plot to look at the relationship between time and then cases. And then I'll run this. So as you can see, if we should draw a line through this, you can see that there's a linear relationship between time on our y-axis and then cases on our x-axis. And that relationship is going to be a positive linear relationship, meaning as the number of products or cases increases, the time that it will take to deliver the package is also going to increase. And I believe this actually makes sense when we apply that to real world. Okay, now let's run the code for looking at the relationship between time and then distance. So I'll go ahead and run this as well. So we first looked at time and cases. Now let's see time and distance. If we draw a line through this, we'll see that there's indeed a linear relationship between distance and then time. And that relationship is a positive one, meaning that as distance increases, the time it takes to deliver a package is also going to increase. And I believe this is practical because if you are trying to deliver something to someone and the distance from where you are to where you are going to deliver that item is far, it's going to take you a long time to deliver that item. Okay, so now let's go back to our presentation. Okay, so the conclusions that we can draw from our results in SAS is that for that of cases, the p-value was very, very small, less than 0.0001. And so we can reject the null hypothesis and conclude that the number of cases indeed significantly affects the time it's going to take to deliver an item. And then for that of distance, the p-value was also very, very small, 0.0009. And this also indicates that distance significantly affects time as well. Okay. And now we are going to talk about assumptions of multiple linear regression. This is very, very important because multiple linear regression relies on several assumptions to ensure its validity and reliability. So in simple terms, to ensure that our prediction is valid. And so there are 4 assumptions. The first assumption is linearity. That is, there should be a linear relationship between the dependent and independent variables. And we previously checked that through the scatter plots. You can also use the residuals versus the fitted values to check that. Another assumption to look out for is independence of errors. The residuals should be independent. And there are various statistical tests that can be used. A very popular one is the Devin-Watson test. And we can also use the residual plots as well. So the third assumption is homoscedasticity. This word is very, you need to be very cautious when you're pronouncing it. And it says that the variance of residuals should be constant. One way to check that is the residual versus the fitted value plots. And our final assumption is normality of residuals. That is, residuals should be normally distributed. We can use histograms, kill plots, Shapiro-Wilk tests to also test for that. The histogram is the simplest way of checking for normality. Okay, let me just quickly go to SAS to show you how some of these assumptions work. Okay. So I need to run them already. So from this histogram here, you can see this was just checking for normality. So once there's a bell shape, so we can see this bell here. That shows that the normality assumption was verified, and indeed it is. Yeah. And this also can be used to check for the linear relationship, this and that. Okay, so let me go back to our slides. Okay. So stop here and then take any questions that you might have for us concerning what we've spoken about, presented. Those on that, you can feel free to unmute or put your question in the chat. Okay.
I'm following on the SAS demand. I just observed that it's like I don't have this data set that you're using to run the. The only thing I have is I don't think it's sent to us. This one, this particular one. I think it's. Oh. Okay, then we can